Hello. In this video, we are going to explore quadratic functions. Previously, we have learned that quadratic functions have a standard form of f of x equals ax squared plus bx plus c, where a, b, and c are just numbers, right? We know that this is a polynomial function of degree 2. We're going to learn more about polynomial functions as we move throughout this second unit. It's going to have two solutions. The graph is going to be the shape of a parabola, which, if you recall from Algebra 2, is just a U. And it has an axis of symmetry, a line on which you can fold the graph in half. And it has a vertex, which is the max or min of the function, which is the turning point. So standard form example. So we have f of x equals x squared minus 4x plus 4. So this standard form we could do a lot with. We could factor it, use quadratic formula, but right now we're going to look at graphing it. We know that it has a power of 2. That's what tells us it's a quadratic. It has a 1 in the front. Since that 1 is positive, it's going to open up. It has a plus 5 back here as the c. So that means the y-intercept is 5. At this time, let's begin finding our axis of symmetry. Recall, your axis of symmetry is x equals negative b over 2a. In this case, our negative b being negative 4. So negative 4, okay, you still have to include the negative from negative b, all over 2 times a, which is 1. So a negative 4 is positive 4 divided by 2 is 2. So now let's find our vertex. We find our vertex by taking our x that we found for axis of symmetry and plugging it into our function. So now we have 2 squared minus 4 times 2 plus 5. 2 squared being 4, negative 4 times 2 being negative 8. 4 minus 8 plus 5 is 1. Remember, you can enter that step in your calculator all at one time. So our vertex is 2, 1. We plugged in our x, we found our y, we have our x and our y to make an ordered pair. So let's look at the graph. Now, on this graph, this is the graph of the function. We see that we have a y-intercept of 5. We already noticed that it opened up as well. We have an axis of symmetry, and guess where that crosses the x-axis at? At 2, just like we had determined. And the vertex is indeed 2, 1. So we had found all these critical points that translated directly to our graph. What about when we have an equation that's in vertex form? Remember, whenever we graph with vertex form, we get to use our translations, which make our life so much easier because we don't have to do very much calculating at all. We still see the squared, so we do know that this function is a quadratic. We know that it has a positive 1 in the front, so we know it opens up. It has a minus 2 on the inside, which means it moves to the right. Remember, whenever anything's being added or subtracted to the inside, that's going to be the opposite sign. If you do not remember these translations, you need to go back and watch our translations review video from before we even began Unit 1. So the minus 2 on the inside moves us to the right. The plus 1 on the outside moves us up 1. That means that our vertex is 2, 1. That means from our vertex and our axis of symmetry, they share the same x. So our axis of symmetry is x equals 2. Looking at this graph, we see that our vertex is 2, 1. We see that our axis of symmetry is x equals 2. Okay? If you notice, this is actually the same function as the previous example. However, this was just written in a different form. What if we solve by factoring? We have x squared plus 3x plus 2. This is a very basic example. Remember, before we can even begin factoring, we have to have this function set equal to 0. So if it wasn't set equal to 0, that would have been the first thing that you did. Remember, last year we said a times c. In this case, our a is 1 and our c is 2. 1 times 2 is 2, so we have to find the factors of 2, which are only 1 and 2. We need 1 and 2 to add to equal 3. The plus in front of the 2 of the function tells us to add. The plus in front of the 3 tells us that we want a positive 3. So we're going to add to equal 3. Remember, whenever this especially comes into play whenever our a is not 1, but we have to take these 2 factors and put them over our ax. And our a, this case, is 1, so it's not really going to change anything. But if it wasn't 1, then it would have come, be a lot more critical. But we're going to put it over ax, and then we're going to fill in our parentheses. Remember, our bottoms up, whatever was on the bottom went first in the parentheses. Now, we notice that our 1 over 1x, our 1 is positive, so a plus needs to go in front of it. And our 2 over 1x was positive as well, so a 2 needs to go in, a plus needs to go in that parenthesis too. Okay, now this problem told us to solve. That means I need x equals x equals. So I'm going to take both of these equations and set them equal to 0. X plus 1 equals 0, x plus 2 equals 0. To get x by itself, I need to subtract 1 from both sides. So now x equals -1. Same thing with x plus 2 equals 0. I need to subtract 2 from both sides. So now we know that x equals -2. And that is both of our solutions. So now we have indeed solved this function by factoring. What if I asked you to solve by the quadratic formula? Oh my gosh, we love the quadratic formula. -b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac all over 2a, all over 2a. I hope after watching this video that song is stuck in your head for like 3 days. At least we're not in class and I'm not making you stand up and sing it. All right, so 2x squared plus 5x plus 1. We're going to solve this using our quadratic formula. That is our song. How wonderful. So we know that our a is 2, our b is 5, our c is 1. If that function would not have been set equal to 0, I would have set it equal to 0. If it would not have been written in descending order, I would have done that as well. So I need to plug it into my quadratic formula. So -b, our b is 5, plus or minus b squared. Once again, our b is 5. Minus 4 times a is 2. Minus 4ac, our c is 1, all over 2a, which is 2. Now simplifying our square root, 5 squared is 25. -4 times 2 times 1 is 8. 25 minus 8 is a 17. Now, -5 plus or minus the square root of 17 over 4. Can I square root 17? Well, I can, but I'm going to get an irrational number, right? So I'm going to leave that as the square root of 17. I do know that this represents both of my answers. If I could leave it like this, or I could rewrite it as -5 plus the square root of 17 over 4 and -5 minus square root of 17 over 4, whichever way you prefer. So if I'm not mistaken, that concludes our presentation, our video on solving quadratic functions. That was a real quick review of a whole lot of stuff that we learned last year. So hope this video helped dust off those old files.